So as with a lot of the statistics that we've been working with, correlation is another one that we can use our graphing calculator to help us with. So notice I've got your screenshots over here on the left, I've got your instructions here. I'm also going to be walking it through with you on the calculator. So calculator's on. First step here is something that only has to be done one time, and then after that you can skip it. It's just a setting that needs to be changed in your calculator, and then after that we can get started. So we're going to start by pressing second 0, and then you are going to scroll down until you come to diagnostic on. And again, this is only something we have to do one time. After this, we won't do it again unless your R value doesn't show up, and then we will have to do it again. So diagnostic on should be on. You're going to press enter again. It says done, and we can go ahead and start. Okay, so we're going to go to stat 1 to edit, and if you have anything in your columns, you're going to go ahead and delete those. So highlight the L1 and the L2. You're going to clear and enter to get rid of that. And then I'm going to leave mine here because I need them for just a minute, just to show you an example. But you would enter your own values in now on X and L1, Y and L2. Then notice we're going to press stat again. We're going to go to the right to calculate, and we're going to press 4 for linear regression. Okay. Now on the back side of these notes, you notice that, oops, I'm sorry, wrong page. Back side of these notes, it tells us to make sure that our lists match. So X was L1, Y was L2, so that's correct. So we're going to go on down to calculate and press enter. And here is our statistics that we're looking at. So first off, y equals ax plus b is that slope-intercept form for a line of best fit. So to find the line of best fit, we would replace the a and b values from here on our calculator into the formula. A represents the slope, b represents the y-intercept. And then we also have this r value. So if ever the r and the r squared don't come up when you do a linear regression, just go back to that first step and put that diagnostic on again. Sometimes when we clear calculators or reset them, it may turn that back off. So we would just go in, turn it on, and then you would continue. So r represents our coefficient correlation. That's our value that is going to be our strength of our correlation. Okay. All right, so after looking at the calculator, we're going to look down here for just a minute to take just a couple more notes just to remind ourselves of what we're working with here. So first off, remember that when R is a negative value, that means that the correlation is negative. When R is a positive value, the correlation is positive. And when the closer R is to 0, the weaker the correlation. Okay, so notice here we have an R of positive 0.82. So the fact that it's 0.82 means that it's a positive correlation. The fact that that number is close to 1 and further from 0 makes this a strong positive correlation. Okay, on the opposite side of that, our R is equal to a positive 0.18. Here it's a positive again, but it's closer to 0, so we're going to call this a weak positive correlation. And just by looking at it, that scatter plot without the trend line looks very much as a no correlation. And because it's so close to 0, you could probably go the route of calling that a no correlation as well. Here we have a line of best fit. It's a negative 0.97 for our correlation coefficient. So this is going to be a negative, and because it's so close to 1, we're going to call this a strong, it's a very strong negative correlation. And then down here we have a negative 0.27. So it's a little bit of a correlation, you can see that, but there's a few values in there that make that a weak correlation. It's closer to 0, so it is going to be a weak negative because it's a negative value correlation. Okay, notice that I've also included in here a line of best fit. That's our values from our A and B that we've plugged into our equation. Okay, so That's our slope and our line, that trend line. So that's the line here that we have represented. This is the equation for that line. Okay. And then one other thing that we want to talk about is correlation. Does not always mean that causation has been demonstrated. So just because two values are related doesn't mean that one causes the other. So for example, if we're looking at ice cream sales and the temperature outside, there may be a positive correlation between those numbers, but the temperature outside may cause people to want to buy more ice cream, but ice cream doesn't necessarily cause people, higher sales in ice cream does not cause the temperature to rise. So you have to think about that causation factor there, whether that there's a cause and effect if one of those variables causes the other or vice versa.